So I'm going to help you understand the difference between two events that are associated and two events that would be independent. Okay, so my first example here, we're just talking about rolling rolling two dice and looking about to see if we get a sum of 7. So I've actually done some color coding here. Okay, the red and the greens are ones that give you a sum of 7. Okay, because my second probability though is going to be the probability of getting a sum of 7 given one of the dice is a 4. So what I did is the black ones are where the one of the dice is a 4 along with the green ones. So the green are both a 4 and a sum of 7. Okay, so if I look, the probability of getting a 7, okay, you'd say, well, there's actually 36 total possible outcomes, so my denominator is going to be 36. And if you look at how many are a 7, remember that's the red and the green circles. There should be 6 of them. There's these 4 red circles and my 2 green circles. So the probability of getting a 7 when you roll 2 dice and add their dots together is 6 out of 36. Okay, and we would denote this just for notation wise for when I explain later. Probability of getting a 7, or just write it that way. Okay, now if I look at the probability of getting a 7 given one of the dice is a 4, now what I'm trying to do is find the probability of a 7 given that one of them is a 4. And again, I'm just using very shorthand notation here. Okay, so in this case, I'm only considering those that have one of the dice being a 4. So remember that was the black ones, well, and the green ones. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 of them that have a 4 as one of their rules. Of those 11, 2 of them have a sum of 7. Okay, so remember the definition for two events to be independent. That means knowing that one occurred does not change the probability of the other occurring. If you look here, the probability of rolling a 7 is 6 out of 36. But if I know one of them is a 4, then it's 2 out of 11 that you would actually have your dice be a sum of 7. So in this case, I would say the two events, right? The event that the sum of the dice is a 7, and the other event would be that one of the dice is a 4, are going to be associated because these two probabilities are not the same. Okay, so knowing that one of the dice is a 4 changed the probability that your sum was going to be 7. Okay, so let's look at a different example. Okay, here's with a deck of cards. Okay, so my first question here I'm going to ask is, what's the probability of drawing an ace? Okay, so if you look at your deck of cards all together, and again I'm going to use just some shorthand notation here, we're looking at the probability that I have an ace. Okay, so that means that there are 52 cards altogether. Okay, and of those 52 cards, 4 of them are aces. Okay, and that actually reduces down to 1 out of 13. Okay, on tests and quizzes I don't really care if you reduce them all the time or not. Okay, my other question is, what's the probability of drawing an ace given that the card is black? Okay, so I'm just going to use some shorthand notation. The probability of drawing an ace given that my card is black. Okay, so how many of the cards are black? And that would be the spades and the clubs, and there's 13 of each of those, so that's for a total of 26. Of those 26, how many of them are aces? That's this ace of spades and the ace of clubs, so there's 2. Okay, and you notice that also reduces down to 1 out of 13. Okay, so now my two events, drawing an ace and drawing a black card, those would be independent events because knowing that the card is black didn't change the probability that it was an ace. So those two events are going to be independent. Now you notice the two examples I did it all mathematically. I did not try to reason anything out. There's a couple questions in the book where they might ask you to reason out the answer, but most of the time you're much better off looking to see if you find these two probabilities. Are they equal? If they're equal, then they're independent. If they're not equal, like in this example, where this event has to be the same as that, and then that means they're associated. Okay, so let's look at one in a two-way table. Okay, so here I have a two-way table, and this is actually just an example in the book. Okay, we want to find the probability that a randomly selected person is married. So we're going to do the probability that they're married. So I look in the married column and I see that there's 408 total that are married. Okay, so that'll be 408 out of everybody, which was 665. Okay. Sorry about my writing, I'm just trying to write with my mouse. Okay, if I do that division, which I think I'd already done. Oh, hold on one second. Let me pull my calculator up here. So it's 408 divided by 665. Okay, I get 61, about a little over 61%. Okay, so 0.6135. Okay, now my next question is, what's the probability that a randomly selected person is married given they didn't graduate from high school? So again, I'm just going to do shorthand notation. The probability that you're married given no high school. Okay, so remember this time, because it's given, I'm only looking at the no high school column, right, which is these people here. Okay, so that means that my denominator, okay, that's going to be 125. Okay, of those that have no high school, how many are married? That's 70. So it's 70 out of 125. Okay, which again, if we calculate that, go back to my calculator here, that's 70 divided by 125. I get 0.56. Okay, so both of these are talking about the probability that you're married, except one is given information. Okay, they are not the same. So what this tells me is, if I know that you didn't graduate from high school, okay, then you're going to have a different probability of being married than if we just talk about everybody together. So knowing that one event occurred, in this case not graduating from high school, changed my probability of you being married. Okay, that means that these two events again are associated. Okay, your marital status is dependent on your education level. Okay, so or those two things are associated. So your marital status is associated with your education level. Okay, and just, I mean, you can find any probability here of married given something. So what's the probability that you're married given you just graduated from high school? So in other words, you graduate from high school but you don't have any college. Okay, so in this case I would be looking at the people in that row right there. Okay, so my denominator is going to be 397 because I'm only considering those, right, that graduated from high school. Okay, and of those, right, those that are married is this 240, so my numerator is going to be 240. Okay, so grab my calculator again. So I have 240 divided by 397. That gives me about 60%. You actually notice that that one's a little bit closer than this one was. Okay, but there's still, it's not equal. I don't remember the exact percentage, but I think it was 0.6 something. 0.6045. Okay, so your education level again is associated with your marital status because these numbers are not coming out the same here. Okay, in this case, you're actually less likely to be married if you didn't graduate from high school, right? You're actually a little less likely to be married than the general population if you actually only have a high school degree. So hopefully this helps understand the idea of associated and independent. Okay, the easiest way to do this is mathematically. Calculate. Sometimes if on a test or a quiz, I even have you calculate things like this ahead of time. You can just look at previous answers, okay, and you can just say, well, these two answers aren't the same, so that means they're associated, or these two answers are the same, so they are independent.